Okay, good morning, class. So today we're looking at trigonometric ratios. And we're looking at examples for exercise 7.2. Examples for exercise 7.2. And this is on page 2. We're reading from which page? 226. Okay, this is for exercise 7.2. Exercise 7.2 is on which page? 227. Okay, so this is also something we have dealt with last year as well. Did we do trig ratios identities last year? No, okay. So a trigonometric identity is a mathematical statement that is true for all values of the angle except those for which the statement is not defined. When is something not defined or undefined? When the denominator is 0. Okay, that is when it's undefined. The two fundamental identities, write this down. The two fundamental identities are tan of theta is equal to sine theta over cos theta, and sine square theta plus cos square theta will be equal to 1. Very important. You find the fundamental identities. Okay. We can also write this identity. We can also write the identity sine square theta plus cos square theta as. So what they did was they took cos square theta over the equal sign becomes sine square theta equals 1 minus cos square theta. Can you see that? On the other hand, if I had taken sine square theta over, what would it be? It would be cos square theta is equal to 1 minus sine square. Okay. So for the next couple of pages, as you turn the page and you do trigonometry, you write on top, tan theta is equal to sine theta over cos theta. And next to that you write, sine square theta plus cos square theta is equal to 1. In our head, or in our mind's eye, we know that cos square theta is equal to 1 minus sine square theta. We also know that sine square theta is equal to 1 minus cos square theta. Okay. By writing it continuously, you guys will start remembering it, okay? And if you apply it all the time as well. Okay. Then we are told that the two identities can be proven using the definitions of the ratios as shown here. So I'm going to prove this to you quickly. So, we must prove that tan theta is equal to sine theta over cos theta. So let's go with the right hand side first. Right hand side. People, remember if that's x and y, that's your y and x, not so. So what does tan stand for? Opposite over adjacent. So in other words, your right hand side is going to be y over x. Not so. Now I can prove that your left hand side is also y over x at the job. Not so. So let's go with the right, sorry, this is the left hand side. No? Left hand. What makes this the left hand side? It's the left hand side of the equal sign. Does that make sense? And then what do we call this? The right hand side of the equal sign, in other words. Okay. So let's go with the right hand side. What is sine equal to? Sine theta. So what's my opposite? Y over R. That means what? Divided by cos. What does cos stand for? Adjacent over hypotenuse. So it's going to be x over. So this is going to change to multiplication, tumble and times. So it's going to be y over r multiplied by r over x. So that cancels, which is equal to y. So what can I, we have just proven now my left hand side equals my right hand side. Can you see that, people? Which is equal to the left hand side. Okay? You all understand? Is there anybody that's confused? Okay. So now, you have just proven that tan theta is equal to sine theta over cos theta. Right, let's look at the other fundamental identity, the square identity. Let's go to the left hand side. That's your left hand side, not so. Now sine theta is what? Opposite over hypotenuse. Not so. So that will be y over r, and it must be squared plus cos. What does cos stand for? Adjacent over hypotenuse. So it's going to be x over r, and it must be squared. So in other words, it's going to be y squared over r squared plus x squared over r squared, which is the LCM is r squared. So it's going to be y squared plus x squared. Not so. But now from Pythagoras, you know the Pythagorean theorem. If I apply the Pythagorean theorem here, what would it be in terms of Rx and y? It will be r squared is equal to y squared plus x squared. That is your Pythagorean theorem. No? Your hypotenuse squared is equal to the sum of your other two sides squared. Not so. But people, we just proven now that x squared plus y squared is equal to r squared. Not so. So that can be replaced with r squared. So therefore, your left hand side is equal to r squared over r squared, which is equal to 1. Which is also equal to the right hand side. Okay. Now using these fundamental identities, question 1 says, use the fundamental identities to simplify the following expressions. Let's look at the first one. A. Okay. So we're going to say that tan theta multiplied by cos theta. Okay. So what can we do here? Sine theta and tan theta multiplied by cos theta. What can we change? We can change tan. And tan can be written as sine theta over cos theta times cos theta over. What's going to happen now? Cancel. It will give us now sine theta. You guys understand? Easy, no? Let's go with B. You got 1 minus sine square theta over cos. Like the identities you understand, no? Tan theta is equal to sine theta over cos theta. Also, sine square theta plus cos square theta is equal to? Okay. Now looking at B, what can be done there? Sorry? Okay. So 1 minus sine square theta can be what? cos theta. Nice. So it will be cos square theta over cos theta. So what's going to happen? Cancel. Leaves you with cos theta over 1, which is cos theta. People, you guys understand? Jamie, what's going on? Remember, we said earlier on that if you take that over the equal sign, then cos square theta is equal to 1 minus sin square theta. And we took that over the equal sign, we see sin square theta is equal to 1 minus cos square theta. So, sin square theta can be written as 1 minus cos square theta. And if you got 1 minus cos square theta, it can be written as sin square theta. You understand? Now coming back to this here. So, 1 minus sin square theta is cos square theta. Not so? So it will be cos square theta over cos theta. So it cancels and gives you cos theta. Do you guys understand? Let's do the next one. C. Now let's move a bit faster. Am I moving still fast enough? It's fine. Okay. So we got sin x plus cos squared x over sin x. What do you think we're going to do here? Skip? No. No, you don't skip nothing. Yes! Oh, no. LCM. And what is my LCM here? Sin x. So they're going to be sin x. So 1 multiplied by what is sin x? Sin x. Sin x times what is sin x? 1. So sin x times sin x? Sin squared x plus. Cos squared x times 1? Not so. And what is sin squared x plus cos squared x? So in other words, this is going to be 1 over. Okay, you guys got it? Don't lose it, no? Let's look at D. D. Here we got sin x over cos x plus cos x over sin x. What do we do first? LCM. And what's my LCM here? Cos x, sin x. So what must this be multiplied by? Sin x. This must be multiplied by cos x, yes. So what is sin x times sin x? Sin squared x plus cos squared x. And what is sin squared x plus cos squared x? So it's 1 over cos x times. Any confusion? Okay. Now we're going to look at example 2. Example 2 is on page 227. Okay. Here they ask you to prove the following identities. So here the answer is already given. Okay. The answer is given next to the sum. So when you're going to mark your work later on and you see that the proof part, you're not going to find the answers at the back of the book, okay? Because the answers is next to the sum. Okay. So how does this work? Let's see. Okay, this is now an identity. So this is your left hand side. Okay. So what do you think is going to be the first thing I do there? Yes, simplify. Now, we multiply, get rid of the brackets. Not so. It's a conjugate page, so I can multiply the first and the last. So what's 1 times 1? Minus. Sine theta times sine theta? Sine squared theta. In this case it was alpha, no? Over cos squared alpha. You all see that? Yes. Now what do you notice? What is 1 minus sine squared alpha? Cos squared alpha. So it's going to become cos squared alpha over cos squared alpha, which is, hang on, it's equal to the right hand side. And that's how we end off. We say the left hand side is equal to the right hand side. Okay. Let's look at B. No, how do we know which side to choose? We basically choose the one that is the most complex. Okay? So here we see that one was simple, or it was... there is people that works from one and goes back into the left hand side. Okay, but it's more complex. So it's more difficult procedure to work backwards. Okay. Right, so which side do you think we're going to work with in B? Left hand side or right hand side? Left hand side. Alright, so people, is 1 minus sine theta equal to cos theta? No, no? It must be squared. It must be squared. That's number 1. No? Forgot to mention. Otherwise, what if you have tan squared alpha? What would that be? Tan squared theta. What is tan? Tan is sine over cos. So what is sine squared? Tan squared theta equal to sine squared theta over cos squared. What would the tan cubed theta be? Sine cubed theta over cos squared. You guys understand? However, for the squared identity, it must be a square. Okay. Right. So what can be done here? We can change tan. So tan can be written, so firstly this is the left hand side. Tan can be written as sine theta over cos theta times cos theta over. So it's 1 minus. What can happen here? Cos cancel cos, not so. So what are we left with? Sine theta times sine theta, which is sine square theta. And what is 1 minus sine square theta? Cos square theta. We say, hang on, it's equal to the right hand side. Okay, is there any confusion, people? Huh? Okay, at this point we'll stop the video. I know it was very long.